Welcome to The Mixer. I'm your host, Andy Marshall, here again with my partner in crime, Juan Carlos Lopez.
Hello, Andy. Good to be here. Tell me, who is our guest today?
So today we have Eric Topol. Eric's a physician scientist, a renowned cardiologist from his time at Cleveland Clinic. Since then, he became executive VP at Scripps Research, and he's director and founder of the Scripps Research Translational Institute over in La Jolla. He's also, of course, a very talented writer and editor, and he's written several insightful popular books about digital medicine and also artificial intelligence in medicine.
Yeah, I'm familiar with his work on multimodal AI, and I'm sure it's going to be a very insightful conversation.
Great. So let's get stuck in.
Let's go.
Welcome, Eric. Welcome onto the show. Thank you very much for agreeing to come on board. So, there's been a lot of chatter about AI. One thing that really struck me was today I was on my personal Twitter stream. I had the kind of top AI innovations in 2024, what I should expect, yeah? But what it said was, we've got the election year coming up. Essentially, I should expect to find all of these deep fake images of people during the election. And then it told me that there's this kind of pandemic of loneliness among people, among the world, and like AI chatbots are going to be the kind of romantic partners. I just find it really interesting how this technology is kind of permeating every aspect of society, yeah? And, we're going to focus in this podcast on science and how research and how AI is going to affect that. But it's just pervasive, throughout society.
No question. But I do think the biomedical applications are unique because of the benefit to risk ratio is so extraordinarily high, especially if we do this right. So, yeah, I am concerned outside of the biomedical sphere, but since I try to keep tunnel vision on that, I don't lose my optimism.
One thing that I really wanted to kind of explore with you was the editorial that you wrote in Science. When was it? Like September last year?
Yes, on multimodal AI.
Exactly. So these kind of multimodal large language models, I think, are coming, yeah? And the question that's on kind of, you wrote this really thought-provoking editorial where you laid out your reasons for why you think this is going to be important. For the benefit of our audience, can you summarize why you think multimodal AI is such a big deal and why it's such a leap forward?
First, you have to go back to what did we get out of unimodal AI? And it was far more extraordinary than we had anticipated. So many of us thought, well, maybe we could have more accuracy of interpreting scans. And that was superseded by a remarkable discovery that machines could be trained with supervised learning to see things that humans will never see. Unimaginable that we would see that in the retina, for example, that the AI unimodal could be trained to detect risk for Parkinson's, Alzheimer's, years before symptoms would be manifest, heart disease, kidney disease, hepatobiliary disease, and the list goes on and on. I mean, that's just one example of what one can glean via machine training. That's set into a foundation model that I was involved in collaborating with Pierce Keane and his colleagues at Moorfields Eye Institute in the UK, one of the leading, if not the leading ones in the world. And with over 1 million images, instead of having one study after another for all these possible use cases of machine eyes, it could do all of them with one foundation model. But still, what we're seeing the potential now is to take different types of data, not just scans, which was mainly the deep learning era in biomedicine, but also text and speech and audio. So when you start to do that, then you multiply where this can all go. I mean, it truly is a multiplier because let's just take the example of cancer screening today. When we have screening that's based on a dumbed down metric of your age, now it can't be much dumber than that. That it's just your age that you should get screened for breast cancer or colon cancer or whatever cancer. Well, it turns out, there are a lot more younger people, even people in their 20s getting colon cancer. Women are getting breast cancer in their 30s, and so they're not even part of the screening. If that's the best we can do, I'm convinced it isn't. But when you start to put in all the other layers of data, genomics, predisposition, you have family history, all the electronic records, scans that can pick up things that otherwise wouldn't be picked up, liquid biopsy assessment, chip, all sorts of tools that we haven't done yet that I'm convinced we can pinpoint risk so much better. And that's just one multimodal AI going forward. There's also many others that include a virtual health coach, digital twin infrastructure, remote monitoring that's exquisite, so you don't have to go to the hospital unless you're in the intensive care unit sort of thing. So this is the ability to take many layers of data and including real-time biosensors. That gives us a whole new look for what can be achieved in medicine.
Before this, I was kind of doing a bit of research, kind of searching around. So I was looking at the FDA site and kind of some of the, software that's been approved on the FDA site. And, essentially there are a lot of software packages. Yeah, it's like over 500 now that have been approved by the FDA. But these are pretty simplistic, kind of shallow learning models. Yeah. Eric, and I was wondering, like in terms of this type of multimodal model that you're talking about, which these kind of large language models that kind of incorporate many, many different types of data into the model, where are we there? I mean, it seems like, have we had any multimodal AI applications like approved by the FDA?
No, there have not been a single multimodal AI, as far as I know, not even submitted for 510K, no less cleared. So that's a really important point you're making, is that there's now 650 FDA, primarily 510K, but obviously some that were formally approved, AI algorithms. They're all unimodal. The vast majority are scan-related, radiology. And what's really disheartening is that the FDA let these go through with no publication, no availability of the data to the medical community for what it showed. Most of these were retrospective rather than real-world prospective studies. There's less than 100 randomized trials out of all of AI, and that's not even connecting it with the FDA approval process. So what we have is a lack of compelling evidence, and the FDA isn't helping, because they're not holding these companies to the fire of, you've got to make the data transparent, it's got to be prospective, it's got to be really high quality. And now, all of a sudden, we're in a new era of transformer models with multimodal data, all these layers. And, they've been somewhat of a low bar, you could even call it sieve for getting these through. What's going to happen now? Well, on the one hand, the multimodal models will multiply for opportunities, but they could also multiply for FDA promiscuity of giving them a green light when they don't deserve it, which is the theme so far. I mean, there are some really good, just yesterday, there was a AI unimodal called DermaSensor that was approved for use of refining skin cancer diagnosis. I said, okay, I'm going to look this up. Does this have a paper associated with it? And I was so relieved to see that there actually was a manuscript with the data. Isn't that nice? Because most of the time when I look things up on these approvals, I can't find anything. So maybe the FDA is, coming along, but the medical community is not going to get into any significant implementation phase unless the data are transparent and compelling.
No, this is a really important point that kind of resonates with something that I've seen, whether it's, announcements about kind of AI advances, or whether it's even papers. Yeah, is this question of validation, Eric? I think it's really worth us kind of thinking about validation and what we really need in terms of thinking about how do we validate the models and how do we validate the data sets that are used in the models? What do we have in terms of concerns about generalizability, biases in the training data? How do we ensure that the stuff that we're seeing in the kind of AI literature is kind of reproducible in the real world?
Right. There's a real difference between, life science and the language of life with omics and that of medicine. When you're making a sense of evaluation, assessment of a medical AI model, the things that you just highlighted are so critical. So what are the inputs? Are they from diverse people, patients? Is it from many sites or is it just from one place? And how big is this data set? And, so many considerations. But even after you get to the model's putative performance, what is the external validation? What has been done to interrogate the inputs or unintended processing of the data for biases, which we've seen many, many flagrant examples that were often only discovered after the AI model was published or even used at scale. So there can't be enough rigor to make the models as they're used throughout biomedicine as good as they can possibly be. And that's part of the problem we have now is, there's a lot of skeptics that are very reasonably concerned about errors and confabulations and what large language models certainly have a major issue. And in order to override that, we have to prove the benefits, the outputs are overriding. There hasn't been enough attention to that overall. There are some great examples, but it's not the usual model that we get to review as a publication or even as a potential health system that's going to purchase the use of a new approved model. So the other thing just to mention is there's some things that don't require regulatory oversight. And so one of the biggest right now is the ability to have an automated synthetic note of a visit between the doctor and patient. And this is something that's extraordinary that doesn't have to go through any regulatory path because its value is being seen by clinicians as saving them hours a day of not being data clerks, of restoring the actual eye-to-eye contact with patients, of generating notes that are far better than anything we've ever had in our electronic records, and then doing all these downstream functions. So that is an example of how we can advance the field in a way, a sort of rescue mission for a very serious problem practically, which is a breakdown of the patient-doctor relationship and the sense of clinicians having to be data clerks, which they don't want to do. They want to care for patients, of course. So the one thing we have to keep in mind is whether we're talking about pure life science or medical, there's lots of different compartments of how this can be used. Each one is different. There's no issue about a regulatory. If it works, it's great. So that's, I think, something that people, when they just think of AI, they just jump into one part of the story, and it's probably not an adequate way to view it.
Returning to multimodal AI for a minute, where do you see the low-hanging fruit in that field? What application will be the first one that you think can set the standard for this emerging field?
Well, I think the basic theme is, we've seen how we can take the weather forecast and make it orders of magnitude better. And so that's what we're talking about with people, defining their risk of various conditions long before they ever had any symptoms of those conditions. This, I think, is the integration of all the information on a given person, multi-layered, high-dimensional data. And so this is a much more intelligent way, as the cancer example I gave, of just saying, well, you're 50, so you should be, having a colonoscopy every 5 years. So I think this is, one of the immediate goals that we should have is defining risk, whether it's for cardiovascular, cancer, neurodegenerative, whatever the condition is. We can go into prevention mode, which has been a fantasy in the medical arena for decades, if not centuries. We can actually get into prevention if we only knew what the person was at risk for.
So, Eric, I think there's two aspects to this in terms of validation that are really, really important. So one is the models and the other is the data. Can we talk about some of the aspects of the models that we need to think about, like that are really important? Like what needs to be disclosed about the model that's really important in terms of reproducibility in the real world? And then how do we think about the data that's used in the model and maybe that's used to train the model?
Yeah, well, there's a lot of holes here, right? So firstly, we're now in the self-supervised, unsupervised learning era. It's a big shift from what was having experts review the data inputs, ground truths. It was a whole different look. Now it's that the data is basically learning from itself, self-assembly, if you will. And that is a problem with respect to how good is the data. And the problem that we have today is some of these base models like GPT-4, ChatGPT, Gemini, several of the leading ones are non-transparent.
Right.
We have no idea. We just think, well, maybe they have the entire scraping of the internet and they have Wikipedia and 100,000 books. Who knows what's in there, right? But whatever's in there, we know has extensive cultural biases because it's human content. So that's one part. But then, like for example, a incredibly remarkable paper preprint from Google came out last week on medical diagnoses. It was about what they called conversational AI for medical diagnostics. It compared 20 primary care doctors with 20 patient actors for over 120 complex cases. And it showed, out of 26 performance criteria, right, 24 were superior by the Google model. They called it AMY. It's a derivative, a descendant of MedPalm 2 of theirs. At any rate, we have no idea what's in that model. They don't disclose anything, but the data was like, wow. Now, this is somewhat contrived because they have these actors having conversations with either the AMY model or the primary care doctor. And they were rated both by the patient actors and by external doctors as to how good do they communicate, how much empathy, how accurate was the diagnosis, how good was the management plan. And the doctors looked weak, really weak. And it's very impressive. However, what is in the model? We have no idea. We have no idea what the real data inputs were. We know about the outputs, and they're wowzer. So this is a consistent issue: is we have basically implicit trust without having what's really inside. It's going in exactly. How the model, explainability of the model, we don't really know. So it's a very tricky thing, and to assess, is this it? It's not been replicated, of course. There are other studies to suggest some similar aspects of this. So we have to always be skeptical with these limitations until we have a lot more to go with. And transparency we're not there. We're just not there.
To me, this really is the challenge of this, yeah? The fact that this is so kind of opaque. We see with these large language models, I'm trying to think through issues such as hallucination, yeah? So most famously, ChatGPT generates answers to new questions basically by reusing and reshaping its training and comes up with fictional, unverified information like references that don't exist and unverified information. People have talked about this like these models are like stochastic parrots. So to me, this really is an issue. Yeah. So I've been kind of trying to think through this in terms of, how do we think about how we apply these models in terms of the clinical realm? And to me, even if most model output is of high quality and most training data are reliable, and you get like results that are trustworthy, the problem is that the recombination and the kind of way in which the models pass this data in a new context may lead to prediction failure. So in the research world, we're interested in how you use this to predict hypotheses that you can then test experimentally. But in the clinical world, you're really interested in what's this going to tell me about this patient. So if you have high quality training data that's reliable and trustworthy, the recombination of these data into new answers in a new context, you have no guarantee that the model's going to come up with something that's going to be prediction failure or some kind of completely left field answer. And kind of going in and merely improving the accuracy of the models, feeding more data or fiddling around with the algorithms kind of seems insufficient, because in a way, in the clinical realm, the more accurate you make the model, the more the users are going to rely on it. And the more they will be tempted not to bother in verifying the answers. So how do you deal with that issue, Eric? I've kind of been thinking about this, and I don't really have a good answer.
Right. No, I think it's important to be cognizant of this, and something I think about all the time. But remember, GPT-5 will be out in the weeks ahead. We're still early. I mean, even though transformer models got their start in 2017, it was only the end of November of 2022 when we really launched to the world. And we'll see better performance with respect to confabulations and overt errors. But in the medical sphere, I'm not as worried about that because, for example, you should always be checking references that are, but if you get a diagnosis, are you ever going to have a diagnosis from a GPT model that you're going to go with and have the patient undergo surgery without a doctor oversight who has, wisdom and experience? No, I mean, there's a human in the loop factor that I think is important, and that, back to JC's question, which is improving the accuracy of diagnosis. I've got another science essay coming out on the 25th, a week from today, on that topic, because when you have all the layers of data, you're going to have a much better chance of getting an accurate diagnosis, which, by the way, is a big problem today in medicine. We don't fess up enough about it. There's not enough work that shows how bad of a problem it is. But we will get better diagnoses, but some of them will be wrong. Just like, I mentioned that comparative study of the actors, patient actors and the doctors. I mean, that not every one of those AMI model outputs was accurate, but they were more accurate than the doctors, that's for sure, significantly more accurate. So again, the fear of the fakes and the promotion of disinformation, misinformation, and all these other things, I'm not as worried about it in our world. We need help. We need a rescue. Outside of medicine, it's much more of a problem. Doesn't mean that the things you brought up, Andy, are not serious matters. It's just that that ratio of benefit, I think, is more favorable.
I mean, this point that Andy brought up is certainly of interest, but to me, the benefits clearly outweigh the risks. Thinking particularly about low-income countries, right? So they don't have access to specialists, but they can have access to these kind of diagnoses. Right, so the number of times that the model will be right will supersede the number of mistakes that it can make. So to me, I think that these models will only get better. And if there are mistakes, think about people with ultra rare diseases, right? They can spend 6-7 years looking for a diagnosis. So we're not very good anyway, particularly in those cases that are very unusual. In the case of more common diseases, I think that the models are going to supersede a lot of what can be done, and I can see that as very beneficial, particularly, as I was saying, for low-income countries. But to me, the question, returning to some of the earlier points we were talking about, is performance is going up.
Right.
It seems that regulatory science isn't really catching up, and an adoption is uncertain, right? So if you're a doctor, how confident are you that this is something that you should adopt or not? So to me, the question is, what do you think is going to influence more the adoption by clinicians? The increased performance or an overhaul of regulatory science? And related to that, how can we go about overhauling the regulatory science, which seems to be quite like lagging behind?
Well, that's a nice summary, JC. I like that, how you process that. I agree with you. I'm worried that the FDA won't step up here and show they have some teeth and they really demand, higher level proof of whatever they're assessing. I think the 510K path is a problem here, frankly. Where are the prospective real world studies, not retrospective data sets? Where are, if possible, randomized trials even? So the quality of data presented to them, they're too lax about giving ability for commercialization. Now, the implementation is weak now in the health systems around the world. I do agree with you that the advantages in low and middle income countries is extraordinary. We could actually reduce inequities that exist because of the capabilities that you outlined. I mean, I've seen many examples of this. There was a randomized study of diabetic retinopathy algorithm in low and middle income countries to show how, inexpensively and rapidly you could get where most, as you know, at least half, if not the majority of diabetics are never screened for retinopathy. And so here, all of a sudden, you've got a way to get on top of that. No less things like imaging through a smartphone, ultrasound, and getting that acquired with someone who has no training, but that the AI says, move the probe up or down and clockwise, counterclockwise, it gets an auto image, video loop or image, and it gets an algorithm to interpret it. That can be done in the hinterlands of any place in the world. So that is a very important point, and Saurabh Jha and I have written about that in The Lancet, about how the low and middle income countries could really benefit. And in some ways, they're adopting much quicker than we are in the US and rich countries. But the implementation, my biggest concern is the data are weak for the reasons that we've been discussing. And the medical community is never going to buy into this, except with exceptions as outlined. If it gets rid of data clerk, keyboard liberation, great. But that's not the kind of thing we're actually getting into. The implementation will be very limited and slow unless there's overwhelming evidence that establishes trust, transparency, and, doctors find all this threatening. They've ruled the roost and, kind of owned this space. There wasn't any machine that was going to be capable of any of their work, no less supersede its performance in some respects. So in order to deal with all this, we have an evidence lack that has to be dealt with. And a lot of these companies that are in this space are startups that are not committed. They don't have the funds. They'd like to do these studies, but they just can't. And then, the big tech titans, Google, Microsoft, Meta, OpenAI, the whole lot of them, they're not used to, high quality randomized trials. So we have to get into that. And again, they don't have to be randomized, but they sure have to be prospective and real world. I wouldn't want to bet anything on some retrospective in silico data set to try to change the future of medicine. To me, that's just a hypothesis generating story, not a real proof.
I think this is so important. How do we incentivize the key actors here to do prospective clinical trials and then publish the data from those trials that have placebo controls and they're kind of forward-looking and they're sufficiently powered and they're published in the literature and that gives us confidence. To me, this area is kind of mired in this problem that there's such a lot of overlap with the kind of tech startup and where you don't really need to show the data. You don't need to show the methodology. It's really interesting to me because the AI community is, the research community is really open, yeah? They're very, very pro open science, open data, open methodology. And yet, where the money is being invested in the private sector, we have this kind of contradiction where everything is proprietary, and it's really difficult to kind of get this evidence base where we have confidence.
That's the fundamental problem. That's the nuts of it. That's the fundamental issue today, which I'm not sure how we're going to get there. To JC's point, it would fix, in some respects, even though the FDA is not going to go through a reset, if they had high quality data, if they demanded it, that might help get us to what you're asking about, Andy. But I don't see a solution outside of the regulatory demands, because the funding, the resources of a lot of the companies that are working in this space to raise capital to do the randomized trial, many millions of dollars, doesn't seem like that gets their investors excited.
Right.
And so if the investment community only knew that the better the data is, the more likely that company is truly going to succeed quickly. If they only got that. But, the investor community, they want to have de minimis, get commercial approval, get some revenue, short-term gratification. And that model isn't working so far. We've had deep learning AI algorithms approved for several years. How many of them are in practice being truly adopted at scale? Very few. Most of them are back office operations things, not actual care of patients. So whether it's the investors, whether it's the leaders of these companies, whether it's the FDA, I don't know how it's going to get on track. I'm worried about it because it's going to slow everything down. And then there'll be a medical AI winter where all these people saying, oh, there's nothing here. Where is the great revolution after all, kind of thing.
This is such an important point that you're making, Eric, because the way I think about this is that if you kind of boil down this problem, there's two parts to this, yeah? There's the algorithms, and then there's the data. And to me, it's very low bar for entry into the algorithms. And I appreciate, like, every now and then, somebody's going to come along with a really kind of innovative way of thinking about data. But really, that's very, very rare, yeah? So the models themselves are not particularly, exciting. This is one of the problems we had when I was at Nature Biotech. We were thinking about the models and how they're applied to the data. But access to the data becomes the most important thing. So I've tried to think about, where is the value here? Where's the gold? Is it the models or is it the data? Then the other thing that I just kind of want to interject here is the whole kind of machine learning AI field is very open. And yet, if you look at translation, essentially everybody's proprietary about the data. So you have kind of pharma companies, they just want to, hold on to the data here, yeah? They don't want to open up their data and let everybody else work with it. So How do you think about how do we go forward? Because to advance, it seems like you want the data to be open and the models to be open and then, science to flourish. But in fact, in the situation that we have is a very balkanized, kind of siloed situation in which, healthcare systems, hospitals keep hold of the data, and then the models themselves kind of exist out of that.
Yeah, and I think it's inseparable because it isn't just the data, it isn't just the models. I do think that much of the concern about bias itself isn't as much the model as the embedded biases of input. But overall, they're so entangled, interdependent. If we had a commitment to do this right, and everyone involved, not just whether it's academics, whether it's throughout the whole continuum of the different types of companies that are in the space and our regulatory bodies, eventually we will get there. But instead of many years for some of the most aspirational goals that we've been talking about, it could be really accelerated. But I don't see yet that overriding commitment that we got to do this right, and we have to be transparent, and we have to, get to real world, not of this in silico stuff. I mean, there's so many shortcuts that are being taken now, and I hope that people will realize that that's not in our best interest, none of our best interests, no less patients, of course. So, I remain optimistic because, all these things are eventualities. It's just a matter, is it going to take 15 years or 3 years? And it's up to us.
Elaborating a little more on this issue of the data, there are 2 points that I think are important to discuss. The issue of data standards. How are we going to go about developing standards? Because who's going to take the lead? Who should say, okay, this is going to be the standard for this data? Without standards, I find it hard to see how we're going to take full advantage of this. That's number one. And number two, the issue of data ownership, right? Andy was already alluding to the fact that pharma companies think about all the data as proprietary. And I'm thinking about some of the recent lawsuits that we've seen with book companies and people saying, "Oh, but why did you scan all my stuff to train your ChatGPT model?" Are we going to see that in biomedicine? Are people going to sue firms because the data was used without their consent? Or large hospitals, are they going to be saying, "Oh, no, you're going to have to pay us because you used our data without the required consent"? How are we going about this issue of ownership and the issue of standards?
Well, the ownership one is, I don't know a better word to describe it than a mess right now. It's unsettled. It's very rocky. Obviously, the New York Times and OpenAI is going to be an important precedent. OpenAI could give a little basis point of their efforts to each of these major mainstream publications, but apparently that wasn't enough for New York Times, and they're going to fight out in court. How much is that going to cost? And how long is that going to take to be resolved? So yes, we will see similar things like that in the medical arena. I'm sure of that because medical data are collected through all sorts of brokers and entities. The health system thinks they own it, but they don't own it. And we're not talking about federated learning here or anything that's being done to preserve the privacy, security, integrity of the data. There's been partnerships that have been established with tech titans, with health systems. Of course, those are all, we're not privy to what's in those contracts. There will be fights about the data. I don't know how that's going to play out, JC. It's just going to happen. You can guarantee it. Just as you could guarantee we're going to see, OpenAI challenged by media. I mean, I had 2 books that are in ChatGPT, and I said, how come I don't get anything? How did they take my books that I worked so hard on? Yeah, and of course, there are many people suing. This is not going to be settled for some time. Now, the standards, there are parties working on that, whether they're going to get traction and consensus, but there are different groups that are definitely on that, and we'd love to see standardization of data. Yes. I'm more optimistic that will occur than in the short term getting settled about ownership.
Who are those groups, Eric?
Yeah, I mean, there's several. I'm trying to remember some of the groups that they've been kind of self-assembling recently, writing papers about it. There was one I came across from Singapore. There's a few nonprofits in the U.S. that are organized. The WHO has called for that. I mean, it's coming from many different directions. We do realize that that's an important goal, but I don't know which one has the best likelihood of driving it. But there is consensus that would help, for sure.
Yeah, that's going to be a very big challenge, and hopefully there will be a solution that is satisfactory so that this field advances. We're coming to the end of the recording, and Eric, there's always a question we ask to all our guests. As you may have seen, the podcast is called The Mixer, and the reason is that we try to combine our interest in translational medicine with our interest in cocktails. So the final question is, what is your go-to drink? When you finish a satisfying day of work, what is your go-to drink?
Well, for me, it would be a glass of a good Pinot That's my thing. Yeah.
Oh, fine choice. My wife's French, Eric, so
Wow.
she would very much appreciate that.
So Pinot Noir.
Yes, Pinot Noir, I should say. Right. Yeah, red. Oh, yeah, red's the only wine I would like to drink.
Very good.
Yeah, I really enjoyed it. You two are really sharp, and it was fun, and I'm sure we'll converge again, whether it's on the mixer or all sorts of other opportunities.
Yeah. We look forward to that, Eric.
Thanks so much,
Thank you very much for your time and for your insights.
Thank you. You guys take care.
Well, Andy, that was a very interesting conversation. I learned a lot, and I'm sure you learned a lot too. Now, my one criticism would be that Eric doesn't drink cocktails. Fortunately, he expressed his interest in Pinot Noir, and as you said during the conversation, your wife Delphine knows one or two things about that kind of wines. So hopefully you don't mind sharing some of that knowledge with our listener.
That's right, JC. Delphine's from Medoc, which is on the left bank of Bordeaux, but Bordeaux really isn't famous for its Pinot Noirs. It's more Merlots and Cabernet Sauvignon varieties. The place in France that's really the benchmark is Burgundy. But in recent years, we've really seen these West Coast US vintages coming to the fore, so Oregon, California, and we're going to give a description of some of those below.
Terrific. I hope I can afford at least one of them. If not, I'll stick to cocktails, and I'll raise a glass to you until next time, Andy. Cheers.
Cheers, JC.